Hey viewers, welcome to the practical section of how to incorporate indicator light in a direct online starter. Now before we start, I would like to give you a close view of the auxiliary contact of a contactor. If you can still recall, while I was doing the analysis on the circuit, I emphasized more on the auxiliary contact section, which is where we're actually going to use for the indicator light. So let me give you a close view of how this section is on the contactor. Now, this is our contactor, and this is the auxiliary contact of the contactor. Here we have is the main contact, where we have our load connected here and our input connected here, but here is the auxiliary contact of the contactor. As you can see, we have the normally open NO, the normally closed NC. That's the input of the auxiliary contact. Here's the output. NO normally open, NC normally close. Now, for the green indicator light, like I explained in the circuit, we're going to take advantage of the output of the normally open. While for the red indicator light, which shows that the contactor is de-energized or the circuit is off, I told you we're going to take advantage of the normally closed contact. That's NC input. As you can see, NC input, NC output. This is where we are going to connect our red indicator light. So let's proceed. Already we have on our workbench here is the direct online connection. You can visit our previous video to have a vivid understanding of how the direct online starter is connected. But for today, I'm just going to talk about how to incorporate the indicator light. But before then, let me just give you an overview of the connection. Here we have is the circuit breaker. As you can see on the diagram, this is the circuit breaker. From the circuit breaker, the input is connected to the live conductor. We have a power supply here, the live and the neutral. The live is connected to this circuit breaker. And the output of the circuit breaker, like you see here, one of the output from the circuit breaker is connected to the normally closed contact, which is the stop push button. Our stop push button is normally closed. This is our stop push button. From the output of the stop push button is connected to the input of the start push button. Here is our start push button. This connection from the stop push button, the output of it is connected to the input of the start push button. Then the output of the start push button here, we have connected to A1, which is a COM on the output. As you can see from the output here, connected to A1. This is the conductor, this particular conductor, as you can see, to A1 here. Then the branch we have here to the normally open contact on the auxiliary is these two branches. On this same start push button, this is one of the branch, this is another branch, both connected to the normally open. These are the branches to the normally open, on the auxiliary contact, as you can see on the auxiliary contact. Now here we have is our load. I just connected this other indicator light yellow to show the load. Here we have input to this load. We took advantage of the first two live and this is the neutral. So now when this breaker is switched on, like I said, you push your start push button, you can see the load is on. When you switch off, as you push the stop push button, the load is off. Now we want to incorporate the two indicator light. One of the lights is to show us when the start push button is pushed on, and the other is to show us when the circuit is off by pressing the stop push button. Now first let's introduce the indicator light to show that the coil is energized. From the circuit here we have, like I said, we take advantage of the output of the normally open of one of the auxiliary contacts. So here is one of our auxiliary contacts. That's the output of the normally open contact. Here is it. We're going to take advantage of it. Like I said, connect one of the terminals of our green indicator light. I'm going to connect it to the output of the normally open. Then the other terminal will be connected to the neutral, which is common. Our common here is our A2. So we're going to tap on A2. That will serve as our common, as you saw here. These are common, these are common. So we'll tap from A2 to feed the green indicator light. So I'm going to tap this other terminal to our neutral here. Make sure that the contact is firm. So we have succeeded in introducing the green indicator light. And the green indicator light that will show when the contactor is energized. So I will switch on the breaker and push the start push button. You can see the green light is on, showing you that the contactor is energized and our load is also switched on. So you can see the green indicator light on now. But by the time we switch off the cycle by pressing the stop push button, you see that the green indicator light goes off, because the normally open contact becomes open, goes back to the initial position when the coil is de-energized. So let's look at how the red indicator light will be used to show that the circuit is off. Now what we do is, for what we saw here, we say we took advantage of the normally open contact of the auxiliary contact, and we looped from the lifeline here. So we are going to loop from one of the lifeline here into the input of our normally closed contact. Now we get another conductor to loop. Already we know that from here we have a branch here that goes to the start push button. So we're going to loop from that particular point. So the input of the normally open contact is where we're going to loop into one loop from here. we want to make available a supply at the input of the normally closed contact, so that when the circuit is off, since the breaker will be on and we know that there is a flow of current to the stop push button, we'll ensure that there is a supply here. That's why we are looping this, so that there will always be supply at this input of the normally close. So we're just trying to ensure that the connection is fair. So when we switch the breaker on, there is supply here. Let's verify that using our multimeter. Set our multimeter on voltage. So we have our neutral here, our light here. You can see there's power there. That's our normally input of our normally open, where we look to the input of our normally closed. You can see there is supply there. Okay, now what we succeeded in doing is to make supply available at this point. We looked from our input, we looked from the input of our normally open, we looked the supply there to the input of our normally close. So now the next thing we're going to do is to connect our red indicator light. That is at the output of the normally close. So I'm going to switch off the breaker first, then get my red indicator light, connect it at the output here. This connection I made here is at the output here. So the other terminal will be connected to the neutral, which is common. So I'll still take advantage of my A2, which is neutral or common. So I'm going to connect it at this common terminal. So with this, we've succeeded in connecting our red indicator light that will indicate when the circuit is off. That's when the load is off. So by switching on my breaker, you can see that the red light is on, but the coil is not energized. So this red indicator light is telling you that this coil is not energized yet. So by the time we energize it by pressing the start push button, you see the red light goes off while the green light comes off. The green light is showing you that the load is on. So by the time we switch off the circuit, we'll see that the red light comes off, telling you that the coil is de-energized or the load is switched off. So that is just a summary of how the whole process is, as explained from our circuit analysis. See you next time.